Sean Grover. So today we're going to talk about location intelligence for business with Mapbox, with Snowflake, and I know that Mapbox is everywhere. What can you tell me and our viewers about Mapbox?
Yeah, Mapbox really is everywhere. We have a tremendous developer base. We love our developers. We have about 4 million registered developers that build with Mapbox today. We're in over 45,000 apps, some of the biggest auto manufacturers in the world. And it's really exciting. We've grown from a company that started in a kind of a humanitarian space, building maps and mapping tools for areas of the world that didn't have maps, so that organizations like USAID and others could deliver aid and resources to those areas. And over the last 10, 20 years, Mapbox has completely transformed itself. Just from these maps, now we have a search business. We'll talk about that today in the context of our native application and navigation, which is powering how we move people, packages, and vehicles, all over the world with some of these auto companies that I mentioned, but also big logistics companies, on-demand delivery. So, the company really has changed tremendously, and we've been really lucky to have developers that have continued to use us in a lot of different ways. And I think what we'll talk about today is really exciting, specifically the business intelligence use case and how companies can harness the location data that they gather to make better decisions about growing revenue, optimizing operations. Really the use cases are almost endless.
Yeah, I love it. Like having maps everywhere is awesome, but then you start collecting all of this data and you need to put it to work.
Absolutely. There are so many. We've seen an explosion of IoT devices that are location aware. So the amount of location data today compared to 5 or 10 years ago, it's just very, very different. And companies still struggle to take that data, analyze it, process it, and then really harness it to make great decisions. And that's part of, I think, what we can achieve together with our native application in Snowflake, making the tools available so data analysts and others can really use that data to further their business objectives.
So tell me more about this Mapbox native application in Snowflake. How does that work?
It's really exciting. So I think we've really bought into the vision of native applications. We've seen tremendous growth of Snowflake, I don't know, over the past 10 years or so, with companies, putting their data into Snowflake, sharing their data, and really breaking down a lot of the silos. And so that logical next step of, we have the data now, can we make an application layer to be able to do more with the data? I think we really believe that is a great strategy. And the impetus and the strategy for us is saying, there's a lot of great customers, many of whom we have in common. I think we serve almost 200 of the Fortune 500. I know Snowflake is probably more than that. These companies need to do geospatial analytics. They need this kind of, these tools that we provide, and they're not really available in Snowflake today. And so this combination of, meeting these customers where they are, giving them the tools to do more with the data in this Snowflake form factor, in this environment, with something as simple as a SQL statement, you can access Mapbox APIs, you can perform relatively complex geospatial operations in a way that just wasn't possible before. So what we really want to do is bring these capabilities to the users where they are and make it much easier for them to do the kinds of things that we do at Mapbox. And again, these can really drive great business outcomes for companies as they gather more and more location data.
Yeah, it's funny how a lot of geo-analysis is happening in a different place than where the data is, and now you're bringing these things together.
That's exactly right, yeah.
So traditionally, geo-analysis has lived in a different place than where people have their data, and you're changing that.
Yeah, we are trying to change that. That is a big reason that we built the native application. It makes sense. You have your data, you want to do something with it. It's great if you can just perform whatever operation you want within the context that you're already in, so you don't have to context switch. And one of the great things that we think as well is that someone who's maybe working in Snowflake a lot might be a data analyst, they might not be an engineer. And so we're offering them a way to access our services, which have traditionally been geared towards developers. And now we think we're actually opening up the ability to do this kind of analysis to an entirely new group of people. And that's going to democratize the ability for companies to do this kinds of work. And we think ultimately, in the end, what we really want is companies to be able to harness this data to make better decisions. So that's what we think that we're going to do here with the native application. It's pretty exciting.
Empowering companies to make better decisions.
Absolutely.
Now, how is all of this integrated? Can we look at the details?
Yeah, for sure. So I'm sharing an architecture diagram right here, and actually I have 2 different diagrams. So we actually leverage a couple different ways to sort of integrate. What you're seeing here is how we make use of external functions. So this is specifically for our geocoding service. Now, geocoding, just to take a step back, is the process by which we convert addresses or places into geographic coordinates or vice versa. So the first is called forward geocoding and the second is called reverse. And this is really important. This is where we started with our native application. If you think about the geospatial analytics workflow, just really like any other analytics workflow, the first thing you're typically trying to do is just clean up your data. Data is really messy, especially when data is entered by users. So when you look at address data, typically there's misspellings, there's errors. A lot of times people don't really know what town they're in or what zip code they're in. And so you have to really deal with that. And so in this architecture, what we're making use of is the external function that you can see actually leaves the Snowflake cloud and it goes to the Mapbox cloud. There's an API gateway, and then we actually make use of the asynchronous functionality of the external function. So we have customers that do billions of geocoding requests. We have customers that do tens or hundreds of millions at intervals, maybe weekly or monthly, because they have processes, ETLs, that are really important for their business. And so it's really important that we can handle very large spikes in volume. And so this asynchronous functionality for the Snowflake external function is really important for us to be able to handle those spikes easily and make sure there's no disruption in service. So those Lambdas ultimately come into Mapbox's cloud. They hit our APIs. We process the data, and then we return it through that same structure. And really what's happening here, and the reason that we do it this way, there's a lot of processing. We have a search engine essentially that's doing things like fuzzy match. We're cleaning up misspellings. We're trying to resolve queries that maybe the town doesn't match the zip code or the state doesn't match the zip code. And so there's a lot of work that we do behind the scenes to match and to provide analytics around the quality of the match. That's a little bit different from the way that we do our boundaries work. And so maybe I'll flip to this next architecture diagram. And I can explain a little bit more about this in the demo. But with boundaries, we have a data set. It's really the leading data set on the market for geographical boundaries. So we have administrative boundaries like countries and states, statistical boundaries, postal boundaries, neighborhoods that cover the world. There's over 5 million data elements in this data set. And you can understand, where a point in the world is, what county it's in, what town, what postcode. And so this is really important for data analytics. It's also really important for visualization. And what we've done here is we've actually taken this data set and we've sharded it in a particular way so that we can load it into Snowflake. And with really simple operations like st-intersect, these are native Snowflake geospatial functions. You can do these really great point and polygon lookups, but you're doing that entirely within the Snowflake data cloud. And so it's a little bit different the way that we handle boundaries versus geocoding and some of our other logistics-oriented apps like the functions that give you duration and distance, and when we can go into that a little bit later.
Yeah, I'm looking forward to the demo, but just to reiterate, you are packing all of this inside a Snowflake native app.
Exactly.
Yep. Oh, yeah, and you are leveraging things like external functions, but you're making it work like, yes, this is an API call, but you have ways of making it scale to billions of calls.
That's right, and it's completely abstracted from the user. So the user doesn't really know that there's an external function. They don't have to understand the complexity of what's going on behind the scenes. They do something really simple like select a column from a table, they call our function, and all of a sudden, they can take billions of coordinates and they can understand what address is closest to those coordinates, or what jurisdiction did they fall in, really around the world. And so this is what's happening under the hood, but the great thing is for the end user, they're not necessarily seeing any of this complexity. They're just able to do the job that they want to do to enable the kind of analysis that they're ultimately looking to do.
That's really cool. And then as you have the API calls on one hand, you can also move a lot of computation inside the Snowflake query engine.
Definitely.
And you're moving not only like these queries, but you have all the data as part of the Snowflake data cloud.
That's right. And actually one of the great features of our APIs and just Mapbox's sort of philosophy in general, we allow this kind of storage. So when our joint customers now work with Mapbox, they're able to actually retain that data and use it for analysis down the road, which is actually pretty unique in the geospatial world. A lot of times, companies only allow the ephemeral usage of data. But here, because we know that, for business intelligence users, it's so important to retain those records, to rerun analyses or run analyses in different ways, they're able to keep those indefinitely and facilitate that kind of future analysis as well.
So Sean, let's look at the demo.
All right, let's take a look. So what we're going to start with here, I'm just going to show you this table. We're starting with about 20 rows of addresses. So we have a source address here and a destination address. And we're going to go through geocoding these. We're going to look at the distance and duration to drive between these points. I'm going to show you an isochrone and tell you a little bit about how this can be applied to some business problems. But first, I'd really love to just show you how the geocoding operation works. So I'm going to take this first statement. This is a reverse geocode. You can see it's a really simple select statement. What we're doing is we're taking this latitude and longitude point, and we're returning the closest address to this point. So you can see what gets returned here is a GeoJSON object, and Snowflake does a really great job in the bottom right-hand corner of making this really easy to see. So you can see here, I'll point out a couple important things. You can see the accuracy. Rooftop is the best accuracy for geocoding. This is basically a point on top of a building structure, so it's the best quality that you can get. You also see the context, so where this is. It's in the US, it's in a particular county, in a city. And at the very end, you can see this is the address, 2595 Lucky John Drive in Park City, Utah. And now you know. So this could be a device at the edge, it could be a truck or a car shooting off this lat long, and now you're able to see here's where it is and make sense of it. The opposite you can also do, so now I'm just calling a forward geocode. So this takes an address string and it converts it into a lat long point, but it actually does quite a bit more than that. So again, I just want to show you in the object here, and what we're seeing is the address. So we're playing the address back. We're actually validating it and saying this is a known address, and then we're also showing you the latitude and the longitude. So you can imagine if you have customer records or any kind of addresses and you want to plot them on a map, you want to do some kind of analysis, this is really the starting point. You're taking this address and you're converting it. What's really interesting though is addresses are tricky. People misspell them. A lot of times folks might not know the right zip code or the right town. And so what I'm going to show you here is the same address, but there's a misspelling here and there's also the town missing. And what you see, what's really interesting, if I go all the way to the bottom here, you'll notice that we returned the same address. So we're able to handle this with fuzzy match and other logic. But you can see that what's changed here is the confidence has changed. In the first example, the confidence was exact because this was a perfect address. Here, we're saying, hey, our confidence is high, but it's not perfect. We had to change a couple of the elements to find a good match. I'll show you just one more example. Now what we've done is another misspelling in this last example, and we've actually left off the state and the zip code. What's interesting here is we actually, as you can see in the bottom right, we find the same address, but if you go to the top, we say, hey, the confidence here is low. And so what's really cool and impactful here is that we're able to do all this fuzzy matching, but we're also able to provide this metadata. So what we see is a lot of customers that, they want to analyze records like this, but they might have a threshold. They might want to say, hey, we're only going to look at high quality addresses that have been input. Or, hey, we want to find which addresses are high quality and which aren't. And so in addition to just kind of doing this conversion, we provide really valuable metadata that's very important for the business analyst out there who's trying to analyze really large volumes of data like this, where they're not able to go in and really look row by row. Is this data right? Is this data wrong? So we're going to take a look and apply this to the data set that I just showed you.
So you have here two different functions. The implementation, as we talked earlier, is different for each one, but it all looks the same for the user as part of the native app experience.
That's exactly right. And so now that we've seen how geocoding works, I'm going to run this code, which is basically taking the source and the destination addresses and geocoding them. So we had columns before for each of these latitude and longitude values, and what this function is doing is geocoding these addresses and returning these values. So as we look here, these columns, the lat and the long that were previously null, we've enriched those. And so this enables us now, we can plot these on a map, we can do all sorts of analysis. And we've actually built this tiny little helper function here. You can see GeoJSON IO URL. And what it's doing right now, it's taking all the points that we just geocoded, and it's putting them in this little feature collection. And this is just a nifty little trick that we have. And so you can, in one click, you go to geojson.io, and you can see where these points are on a map. So it's just sometimes you want to, see your data. Where is it? Does it make sense? And so here we can see, we've got some points in the Midwest, the South, Dallas, the Dallas, Texas area.
Our data is all over the map, and we're going to keep playing with this table.
It is. It's all over the map. And so what we want to do now, as the names of the columns might imply, we have a destination and we have a source. And so we are going to call this distance and duration function to see how long it takes to drive between these points and how many meters or how much distance is between them along the road network. And we're going to use this function, distance and duration. So I'll call this function on our data set in just a moment, but I want to show you just a little bit how this works. And so this function, as you can see, takes a pair of latitude and longitude values, and it also takes a modality. So here we're looking at driving, but we also support walking and cycling, which could be important if you're looking at maybe selecting a retail location in a city. Walking actually might be a more important profile than driving. So we have that option. What you get back here is a response object that shows you the distance in meters and the duration in minutes. And it will also show you something really interesting, which is the distance between the point that you gave us and the road network. So if you've put this in the middle of a forest, we'll tell you, hey, actually, it's quite far to get from the point that you've given us to the road, and then we'll show you, then along the road, how do you get to your destination? And what we're going to do now.
And this is the real distance as people experience it.
It is. It's the real distance along the road network as people experience it. And actually, that brings up a great point. One of the really interesting things about Mapbox, I mentioned earlier that we have customers in automotive, Toyota, GM, Rivian, BMW. We also have a lot of logistics customers that are driving around, whether that's on-demand delivery or planned routes. So we have a really good understanding of traffic conditions right now and historical traffic conditions over time. So not only is this distance and duration along the road network, but in this particular profile, we're looking at also average traffic. So you're getting a sense of, the more congested an area is, that might not change the distance, but it will change the duration. And so we will get a really accurate profile of these things, which is really great.
Love it.
And so now what I'm going to do, I'm going to just run this same function again against this table that we've been working on. So we can now see the distance and duration between these pairs of points for the points that we've been working with.
Driving distance, even throughout the US.
Throughout the US and internationally, virtually anywhere. So we're just going to make sure, take a look here. We have our lats and longs, and now we have our distance and our duration. We can do things like sort these. You can imagine if we have millions and millions of rows, trying to find the longest and everything else, we can take a look here. What I want to show you now, so let's put this on pause, and I want to introduce a new concept, and then we're going to bring these two concepts together. Or literally, we're going to intersect them using the intersect. But I want to show you something called isochrone. I'm going to run this function, but I want to explain an isochrone, what an isochrone is. Basically, what we're doing here is we're selecting a point, and then we're saying whether you're walking, cycling, or driving, how far can you get from that point along the road network in a specified amount of time? So what we've done here in this function is we said, hey, from this point, and this is in the Dallas, Texas area, how far can you drive in 60 minutes? And again, as you mentioned before, this is along the road network with average traffic. We've again created this little helper function so we can go to geojson.io and we can visualize this. And you see this really cool, kind of stunning, spidery chart that shows you from this point, here's how far I can get. And this matters a lot, for lots of different use cases. So what we're talking about here is maybe a logistics use case where we're trying to figure out, hey, we're driving between all these different points. Where should we put a warehouse so that we capture the most amount of stores that we're delivering to or the most amount of customers? So there's a lot of use cases for this. And just like before, I've actually done this in the background. I've created this drive shed column, which I'll show you right now. It's taken the points that we had and it's created this object that shows, that basically is the coordinate representation of that spidery chart that we just saw. And you can see if you scroll down here, these are very, very, very large objects because we're doing lots of computation to figure out how far you can go. As I said before, what we want to do really is we want to do something with this. And so what we're going to do now is we're literally going to intersect these isochrones that we've created with the points that we were looking at before. I'm just going to run this and then talk about what we might be doing here. So what we found, this table that we've outputted here, now we have the addresses that we looked at before, and we're counting how many of the destinations that we're delivering to fall within that isochrone. So what we're saying is, if we put a warehouse here, or if we put a store here, now we're trying to figure out, well, how many of these destinations are reachable within 60 minutes? So you can imagine how you can extrapolate. This is a very small sample size here just for illustration purposes. But you can imagine if you have millions of customers, tens of thousands of customers, we're trying to figure out, how many potential customers are within 15-minute walk of this store in downtown in a particular city, or how many stores are within this warehouse if you're trying to choose between different locations. This kind of intersection, which makes use of just some of the native geospatial functionality that Snowflake has to offer, is really, really powerful.
It's so powerful. Just thinking of, for example, if you move a gas station 2 blocks away, the driving time can change so much depending on what street are you putting things in.
Absolutely, absolutely. So we see our customers, again, using this for that kind of planning use case, store locations, warehouse locations, really, really powerful. And so I'd actually love to just show you, I'd love to switch gears a little bit and maybe show you the boundaries demo and what I talked about before. To give you just, again, refresh, boundaries is the leading data set really in the market of, as the name implies, boundaries. So these are polygons around the world There are administrative polygons, postal polygons, statistical polygons. In the US, we have legislative districts, state senatorial districts. So really, and they're edge matched, and they're basically what we call topologically accurate. So there's no gaps, there's no overlaps. And what we've done is we've loaded this data into Snowflake. So now you can perform these kinds of point and polygon operations against boundaries. And so what I'm going to do is basically take the data that we've been working with, and I'm going to call this stored procedure. What's happening right now is we are taking each of those points and we're intersecting those points with each of the boundaries layers. And in the US, we're talking over 10 boundary layers of different types. And we're basically saying, what are all of the boundaries that contain these points? And so similar to geocoding, you can return things like the state, the county, the municipality, but boundaries also has some really unique layers that aren't present in geocoding. Well, first let me show you what the response object looks like. And then I'd love to kind of double click on one of these layers and show you how you can use it to even further enhance the kind of analysis that you're doing. So you'll see now that we have this boundaries column filled in, and I want to try to expand this bottom right-hand piece here. And just to show you not all of the layers, but you can see that in this GeoJSON object, we have, this would be our administrative 0 layer. So that's kind of the country layer. That's the highest, sort of the highest level of granularity. But as we dig down, you can see that we have, here's Kalamazoo. This is a town in Michigan. We get into US Senate districts. And so you can see, we get down State House District 42. So this unlocks political analysis, statistical analysis. What's I think a really interesting layer in the US in particular, because of the data that it unlocks, is the census tract. So you can see here that all I've done is just said, hey, from this boundaries data, just give me back the census tract name. And we can take one of these, and I think I've done this actually, and just pulled up this census reporter, which shows one of the census tracts that we're talking about. And so you can imagine, we started with this address. We went to a point, then we figured out what census tract this is in. And look at all this amazing data that we can now join to this point. So we can look at median age, income, how long people drive to get to work on average, the number of households, and on and on. And so if you're trying to, again, figure out, where should I put my store, or, I'm planning for the future, you not only want to understand the location, is it reachable, but now you can say, oh, these are the types of people on average that live in this area. And, this ability to sort of join to this census data in the US, or, European statistical agencies have very similar data based on NUTS boundaries and things like this. It really unlocks a lot of possibility. And so you can see how you can go from maybe just a single point, and now you've been able to build all of this, and you can do this really interesting analysis.
I love it. Thanks for this demo. Now, as we're recording this, I see that some functions are in beta, some are in private preview. This means you're showing us what's happening right now, but a lot is moving on, a lot is happening.
Yeah, so much is moving. We started, the first thing that we built in the native application was geocoding, because like you saw, that's kind of the foundation. You can't do all the really cool visualizations and analyses if you don't know where your points are, validate that the addresses are valid, and all of this. And so we started there, but as you can see, we do have some of these functions that are in beta. We're constantly building. So we're making these navigation functions available. People can use them now, and we're going to continue to expand on that. So one of the things that we're excited to bring to the table is our optimization API. This is an API that solves the traveling salesman problem. So if you have a route, maybe a truck that needs to make 50 stops, the optimization API will find the optimal route for that truck to minimize either time on the road or distance. There are a number of other parameters that can be tweaked to find the exact recipe that matters. And some customers want to minimize time, some want to minimize distance, and that actually can have pretty different outcomes depending on how you construct the function. So we're excited to bring that, and also to explore other things like Snowpark Container Services. And so I think you're seeing that we're really actively developing here, and we're really excited to bring more and more functionality to the native application over time.
That's really cool and rich. By the way, I'm noticing as we look at the demos, we are recording it today. Some of these functions are in beta, some are private. This is really like developing fast. Where is this going?
Yeah, we are developing fast. So like I said, we started with geocoding because this is really, in the geospatial workflow, this is the first step. And so that was really where we started. We also brought our boundaries in. But as we've grown, we've seen a lot of demand for these kinds of navigation APIs. Customers that want to understand what's my carbon footprint of my logistics fleet, or how do I plan stores, the kinds of use cases that we were walking through. So we've recently launched those into beta. We have customers testing those out right now. It's really exciting. We're adding more. We're planning to add more APIs of this type, like optimization. Optimization is sort of an API that solves traveling salesman-like problems. So if you're an organization that has a truck that needs to make 40 or 50 stops, we'll help you find the optimal route to be able to do that. So that's coming soon. And then there's a lot of things that, in the future we're really excited about that are maybe a bit more conceptual at the moment. Obviously, I've been switching a little bit between Snowflake and GeoJSON.io to visualize a lot of these operations that we're doing. So we'd love to be able to bring Mapbox map visualization into the Snowflake UI. We've been working with Streamlit to do some early experimentation there. And then I think another thing that we're very excited about is Snowpark Container Services, and looking at how we might be able to deploy some of our geocoding, other functionality into Snowpark Container Services to have everything fully encapsulated within the Snowflake environment. So I know that's in, I think, private preview right now. We're talking to the team and trying to understand what that might look like. But I think there's no shortage of really exciting ways that we can take this. And a lot of it will be guided by what customers want and what customers are looking for. So it's been exciting so far, lots of change, and hopefully a lot more to come.
Oh, yes. And the fun part is that we are recording this now. Some things are in private preview, but when people are watching this, it might be already out and with even more cool features out. Now, I want to talk a lot about how this packaging happened, how you made it a native app. But first, let's talk a little bit about Mapbox and your experience at Mapbox. What do you do?
So I'm the head of search at Mapbox. We have, as I mentioned, Mapbox really has its roots in maps.
Yes.
But we have a search organization, which I lead. So we do things like geocoding. This kind of address analysis, which can be used for business intelligence, but it's also used for customers like Instacart. How do I find my address so someone can deliver food or groceries? Geocoding is really used by almost every company out there. So I lead the organization that has geocoding, and we have also point of interest search. We have data products like Boundaries. Another product that's really exciting is Movement, which is also available on Snowflake. This is a de-identified and aggregated data set of all of the telemetry that we collect from our users. So it's very, very privacy focused. But you can see over time an index of human activity around the world. So you can see impacts of COVID in city centers. You can use this also for site planning. You can look at human activity. How is it different on this corner versus that corner? So these are the kinds of products that are part of my organization. And yeah, I've been with Mapbox for about 2 years. I came over from more of the B2C side of things. I worked at a company before, TripAdvisor. But I just really love maps. And even in travel, in so many different companies, location is so integral to the experience that you provide. And I think, on some level, everyone that works at Mapbox is a bit of a map nerd. It's just a very cool domain. It's really visually stunning, and again, such an integral part of so many companies and customer experiences. So it's been a lot of fun so far.
Yeah, I love to see your passion for what you're doing. Now, when you are in this position, you are looking a lot of what the product is, but you also talk a lot with customers. And how's that experience? How do you divide your time?
Yeah, it's really interesting. So, part of why I think Mapbox is such a fun place to work, we are working with enterprises. So we are, trying to solve our customers' problems. But ultimately, you think about an app like Strava, for running and cycling. I love using this app. The map is such a prominent feature of that application. I think it's probably one of the main reasons that people use Strava to map and visualize their runs and their routes and see, where are the heat maps around me so I can find cool places to run, or maybe I'm traveling and I don't know the area. And so we are working with companies like Strava directly, but I think what we have in common is how do we make this amazing experience for the end user? So it's a really kind of, I think, it's really special in that we are B2B, but it's really B2B2C. And so we're trying to solve developer problems, create really great tools so developers can build these kinds of applications. But at the end of the day, we have the end user in mind. So I would say that, yes, we're focused on our developers and our customers, but really with an eye towards making the end user of our maps, our nav, our search, making sure that they have a great day and a great experience.
And you must have this really interesting conversation at Mapbox inside where you go like, hey, we should develop a Snowflake native app. Yep. And at the same time, you're having this conversation outside of Mapbox telling future customers, like, hey, we have this new feature. I use Snowflake customers. We can do this together. How those two conversations happen?
Yeah, I mean, it's really natural, right? Because what we're trying to do at the end of the day, especially when we're talking about the kinds of use cases that we're trying to enable on Snowflake, these are business intelligence, data analytics kinds of use cases. And so for us, we just want our customers to use our services so that they can make better decisions, analyze what they want to analyze. And so they can come to us directly, but if we can offer them a way, maybe because they're a Snowflake customer, because the folks that are working on these problems, maybe they're more data analysts than they are developers, and we can give those folks these tools within the Snowflake environment, I think it's a win-win. So it's great to be able to go to talk to customers and say, we can solve this problem for you, and then we have various ways that you can choose to do that, right? Whether that's through Snowflake, through us directly. And so, a really big part of Mapbox, the philosophy, we think of ourselves as a platform as a service. So we have the Legos, and you can go build really whatever it is that you want. And I think the great thing about the Snowflake native application, it's another Lego, it's another tool that we can offer to our customers to solve their problems. So I think it's a really natural fit within our portfolio, and it's great to be able to find customers that are on Snowflake because we can offer this to them.
Yeah, and it's a great cycle. Like Mapbox develops with Snowflake, we partner on this, and you are getting more customers, and everything is.
Yeah, it's been a great partnership so far. I mean, it's been really great to work with Snowflake, both on the tech side and on the marketing, go to market. It's been a great partnership so far.
When people want to move forward with this, they're really excited. What should they do next?
Yeah, I would recommend in the marketplace. Go into the listings, search for Mapbox. You'll see our native application. You'll see also some of our data products. So we do have our boundaries data and our movement data also available as data sets that you can purchase in Snowflake. But you'll find our native application. You can get started. I think there's a 7-day free trial. You can go try it out, test it out. Of course, they can feel free to contact us. There's contact links if they have questions or feature requests. But I would encourage everyone to go there, download it, get started, and let us know how it's going.
I love it. That's the beauty of the marketplace. First, you started sharing data. Now you can share the whole native app. Just people can install it. What's the experience like when people get the native app? I
think it's really easy. Mm-hmm. We have folks that they download the application, and then they're making their first call within 5 or 10 minutes and, doing some operation like geocoding or, something else. And I think it's easy to work with Mapbox, don't get me wrong. But if you're already a Snowflake customer, you download the app, you're getting started with a simple select statement. I think that ease of use and that reduction of friction is really great. And we see customers, they download it and they're off and running right away. So I think the thesis of bringing these applications to the data cloud, enabling customers to do more, I think we see that playing out already.
This is really, really awesome. I can't wait to play more with this data. Thank you, Sean Graver, for coming today. Thank you, everyone, for tuning in. For developers, we have developers.snowflake.com, where you can go learn more. If you already have Snowflake, go to the marketplace, check out the Mapbox offering, their data, the native application. Stay tuned. We have a lot more coming. Remember to like and subscribe.